Chapter 6 we'll be covering conditional statements. Conditional statements are also known as if statements, and they allow you, or they allow your script to take its own decisions based on a comparison between two values. In English that would sound like, if it rains outside, then take an umbrella, else don't take one. Every programming language has conditional statements, and obviously we will study the ones that we're going to use in Mel. In more technical terms, you could describe a conditional as that a certain action will be performed only when a condition is met. The action that will be performed in this case is take an umbrella, and the condition that has to be met is if it rains outside. Okay. Let's take a look at what that looks like in Mel. I'm going to make a little example. I'm going to start by declaring a variable. I'm going to call that variable x, and I'm going to make that variable 4. And then I'm going to take a good look at the syntax of the if statement, or of the conditional statement. I'm going to say if, open the brackets, if x is greater than 5, then print, open the quotation mark, x is greater than 5. Close the quotation marks, terminate the command. It's always good practice to put this in between squiggly brackets, although that's not really necessary when you have just one line. It is, however, necessary if you have multiple lines, and so it's just good practice even if you have just one line. Just put them in between squiggly brackets as well, it doesn't matter. And then I'm going to say else, and I just copied that, is not greater than 5. Okay, so if I just execute that, so my variable x is now equal to 4, and then I execute this, you'll see that the result is x is not greater than 5, which is obviously because 4 is not greater than 5. And let's say that we declare this variable again, and we cast 10 inside, and then we see x is greater than 5 because x is 10 and 10 is greater than 5. Okay, so that was just to show you a little bit about the syntax. I'll make an example that is a bit more visual right now. Let's say that I create a sphere, and by using a conditional, what I want to do is if the scale of this sphere is bigger than, let's say, 2, then it has to become red. Okay, so the first thing that I'm going to do, I'm just going to comment it. I'm going to put the scale in a variable like so, and the scale is obviously going to be a float, so, and I'm going to call that scale x, or scale z, sorry. And then what I'm going to do is I need a command. Again, be careful that you put it in between back quotes. The command that we already discussed, get attribute, and what I have to do is I have to take the get attribute, or get the attribute of polysphere 1, so that's the node name, and then scale z, like so. Okay, and then I have to terminate my command and make sure that I encapsulate this one in between the back quotes, just like that. So I have that now in there, just like that. You see that it's 1. If I bring up my channel box and I select that sphere, let me resize this just a second, like so. You see that it's 1, and if I were to change that to 1.2 and I declare that variable again, you see that the result is now 1.2. Okay, well, what we have to do next is we have to write the conditional. So I'll just comment that. This is just a comment, right? This is not part of the code. I'm just commenting it so I can form a clear flow in my script, which will become very important later on when your scripts are getting longer and longer. So I say change the color to, let's say, red when, and then this variable, scale x, is, let's say, bigger than, scale x is bigger than 2, like so. So I'm going to say if, brackets, this one here, copy that one. Again, you notice I'm copying a lot, like so, bigger than 2, blah blah. And then what I have to change is I have to set an attribute, namely the attribute of the shader of this sphere. Now, if I bring up my Hypershade, I'm just going to use this. The shader assigned to this is the default shader. It's called Lambert 1. Okay, so I'm just going to keep that. And then, so if that is bigger than 1, I have to use the set attribute, then the name of the node, which is Lambert 1, and then I'm going to change the color to red, so RGB 100, just like that. Okay, and this one has to come in between parentheses. You should remember this from when we covered set attribute and get attribute and things like that. I'm just applying that knowledge we have right here. Else, let's say, let's change that color to black. So again, I'm going to copy this so I don't have to retype everything. I'm going to change it maybe to blue or something like that, instead of black. It's a bit more exciting. Okay, so let's take a look at that. If that works, get the scale in there. Okay, and then based on the if statement, there you go, it's blue. Let's make it bigger. So I make sure that my scale Z is bigger than 2. See if it's bigger than 2. Yes, it's 3.29 right now. So if I execute this command again, it should be red. There you go, my sphere is now red. So as you can see, the comparison is always mathematical in nature. The left side is compared to the right side, so the left side is compared to the right side, and a decision is made as to whether the values are equal or bigger or and so on. And then if they are, the statement is considered true and the given command will be executed. So if this is true, then this. If it is not true, else. If it is not true, then this. Okay. You don't have to have an else statements in there. You can just say if it's true, then this, and no else statement. Okay. Now the greater than sign and the smaller than sign and so on, they are called logical operators. There are more logical operators. There's less than, greater than, equal to, not equal to, greater or equal than, and less or equal than. Now, mind the difference in between a single equation mark and a double equation mark. A single equation mark assigns values to a variable, such as you have here. This is a single equation mark. This means nothing more than you assign this value to this value. So you assign the right side to the left side. If you write expressions in your day-to-day work, you know all this, obviously. But it's very different from the double equation sign. Okay, the double equation sign tests whether two values are equal. We'll make examples of this in a second. But what you do is, for example, you would test if something is 0. There's a big difference in writing, let's say, this one and this one. Okay, over here in this one, you're assigning 0 to the variable called test. In this statement here, you're testing whether test is 0. Okay? If you don't understand, don't worry about it. You will use it all the time, and we'll make a lot of examples so it becomes clear. But it's important to understand that a single equal sign assigns values to variables. A double equal sign tests whether two values are equal. Okay. What we'll do next is we'll create something that is very useful. Maybe I'll just open up the script. Go to my projects, Mel DVD, Mel chapter. What chapter are we again? 6. Chapter 6. And then what I have here is I have the script already, but I just have the pseudocode. The pseudocode is just the comments, okay, which you will normally always do, especially in the beginning. You'll just write out in English what you want to do, and then you will write the real code, the Mel, in there. Now, what I am going to do also is I'm going to open the scene on which we're going to work, so I don't have to spend time creating it. Although it's a very simple scene, though. So this is the final product of that scene. What I have here is I have an emitter, and I have a locator. And the idea is that if I play this, you'll see that the particles die as soon as they reach the height of the locator. Okay, which means that if I were to change the height of this locator, like so, and then hit play again, you see this change. Now this is not a MEL script per se, okay, this is an expression that we're going to write. And although there are a little bit of differences between expressions and MEL, this is a very good example to make you understand what if statements, what conditionals are. Later, don't worry, we'll discuss it in depth in real MEL scripts, but I just want to open with this one. I'll just go back to Maya, there we go, and bring up MEL Studio Pro. And then there's two kinds of expressions. You should know that there's a creation expression which gets executed one time at the birth of each particle, and then there's a runtime expression which gets executed every frame for each particle. So if we were to create this from scratch, I'm just going to delete the expressions that we already have in there. So I'm just going to delete edit like so. Then we can clearly test what is going on. I'm going to start by writing it just in MEL Studio. Okay, so in creation expression, actually I have a PowerPoint of this so we can more clearly discuss it. Okay, so the first example here is killing a particle based on the position of a locator. The conditional statement that we're going to use in English is if the particle's position is greater than the locator's position, then kill it. The pseudocode would be first get the particle's position, put it in a variable, then get the locator's position, put it in a variable, and then compare those two with each other, meaning if the particle's position is greater than the locator's position, then kill the particle. And how do we kill particles? Well, we set the lifespan to 0 in this case. Okay. If you create this scene yourself, you have to make sure that with your particles you indeed have lifespan pp turned on. By default this is set to live forever. Obviously if you write expressions on lifespan pp, you have to make sure that your lifespan mode is lifespan pp, otherwise it's not going to work. Okay, so let's take a look at that. The first thing that we're going to do is we're going to create a creation expression in which we're going to say that the lifespan equals 10, or actually that has to be the lifespan pp, lifespan per particle. Why do we have to do that? Well, because if our particles don't live long enough, they cannot die on time. So we have to make sure that they live long enough to reach that locator so they can die. Then the next thing that we have to do is we have to get the locator translation values and put it in a variable. This is already the runtime expression. Well, how do we do that? Well, it's very easy. Since the locator position is a vector, it's x, y, and z, we have to declare a vector variable just like that, and then we call that, let's say, locator position. I'll call it locpos, and then we have to take care of the syntax of this, of the vectors, so make sure that you write the triangular brackets, and then the locator position is let me just copy that one right here and then say tx. That tx is a shorthand for translate x, so you don't have to write that full. If you paste this in your expression editor, Maya will complete this for you. This, for example, is already a big difference between MEL and expressions. You cannot use, you cannot directly access the attributes of the attribute values of the locator in this case in MEL. If you want to do this with MEL, you would have to use the getAttr command. Now, if I would execute this here, you see that I will get an error message because Maya doesn't know that. It's looking for a procedure that is called locator, and it cannot find this. This is already a big difference between MEL and expressions. But I'm just writing this here because this has a big font so you can easily read it. Later we'll paste it into the expression editor. And then we're going to do the same thing with the particle position, so I'll call this particle position. Now there is an attribute, there is a particle attribute which is actually called position, which gives you the position of a particle. If I quickly shift to the, I think I have a bookmark for this, where my, let me just look for it. I can't find it right now, but I have a, it is a per particle position, a per particle attribute, sorry, that is called position, which gives you the x, y, and z world space coordinates of each particle, of a particle. And then what we have to do now, this is already I already discussed this, but this is the first time we will actually apply this. I have to access the y values. I have to access the y values of these vector variables. You remember that I have to do that by putting a dot behind it and then saying y. Okay, I have to access the second one, y, here. So how do I do that? If I use the syntax for conditional, there I go, and then I say the particle position, when that one is bigger, so I say particle position, like so, but not just particle position dot y, because I only need the position of the particles in y. Same thing for the position of the locator. Obviously, if you would want the particles to die when they go in x or something like that, you could easily do that as well, but then you have to write x here instead of y. So if that one is greater than the locator position, and again the locator position in y, then if that condition is satisfied, then the life span pp of that particle equals 0, and just like that. Okay, so let's take a look if that really works. Let's first see if this continues. So you see that my particles now do not die when they reach that locator. I'm just gonna go in my expressions, and I'm gonna copy those expressions. So in, oh, it's getting a bit confusing because I have a lot of windows open here. So in the lifespan, in the creation expression, I just go like that, create. Okay, that went without error messages. And in the runtime expression, I'm gonna create that. Oops. Lifespan pp, I always make that mistake. It is with a small s. Okay. Okie dokie. And let's test that. Let's see if that one is working. And there you go. Your particles are dying. Now, if you would want to put in some more randomization so they don't really pop off, there's a lot of commands like smooth step and even lint step that can help you doing that. But that is not really the objective of this course, because this is more expressions than it is mel. The only thing that I wanted to achieve with this is to give you a practical example of conditionals. Now, another example is I'm going to show you how I created the toggle for the resolution gauge. You remember in the beginning that I discussed how I have, let me just make my overscan a bit bigger so you can clearly see my resolution gate. You remember how I discussed that I have this resolution gate always on or off because it is assigned to a hotkey, and it doesn't, it checks which camera is active, and then it displays the resolution gate of that, again based on a conditional. So in the second example, creating a hotkey for displaying and hiding the resolution gate, let's take a look what we need to do. Again, the conditional is if the resolution gate for the active camera is visible, hide it. Else, hide it. Else, it means that the resolution gate, oops, that is, sorry. I have to go, there's a little typo here, else show it, that has to be, okay? So if the resolution gate for the active camera is visible, hide it, else show it, okay, obviously. Sorry about that typo. The pseudocode is as follows: get the active camera, which will be a bit of a challenge right now, and then query the resolution gate of that camera. Again, we're going to use the query mode of a command, and then based on this information, if the resolution gate is on, hide it, else turn it on. Okay, so let me open ML Studio Pro and let me open up that script. ML chapter 6, display resolution. There you go. So let's take a look at what happens. Over here again, we have the comments, which are, the comments are just an explanation or the same basically as the pseudocode that I have here. It allows me to remember what I have to do and to put a structure in my script. In chapter 9 we'll discuss how you can keep this organized for longer scripts. Okay, so the first thing that we have to do, that we have to know, is I have to know which camera is active. Now it takes a little bit of looking how you can get that, but the main source is that you check your script editor to see what is happening, and then what I always do is, if I don't find the command, because sometimes commands are not really called the way you would expect them, obviously, I look for scripts on high end that do something similar, or I look for scripts in the Maya scripts directory that do something similar, and then I dissect those scripts and see what I can learn from them. Now from doing that thing, from doing exactly that, I found out that you can get the panel, the active panel, which is this one right here. So if I display my 4 panels, the active panel is the one you see that has the red border around it right now. This one, if I click on it, this is the active panel. So there is a command that allows you to query the active panel, okay? And then there is another command which allows you to query the camera that is active in that active panel. So the first thing that I need to do is I have to query the active panel, and then I have to query what camera is active in that active panel. Okay, so you have to go through 2 steps to find the active camera. Now once you found the active camera, you can query the resolution gate, and then it's very easy to write a conditional for that, so you can turn it on and off. Okay, so to get the active panel, you use the get panel command. So let's look that up. Let's look that up in the Maya help. Get panel. There you go, get panel. This command returns panel and panel configuration information. It has a couple of flags, some of them are really handy. The one that we are going to use is active panel. But you could easily use also, this one is a very handy one, under pointer. Under pointer means the panel that is currently under the pointer. The pointer is the white arrow you see, obviously. So you can query that one as well. But the one that we are going to use, the flag that we are going to use, is with focus. With focus means the one that has the border around it, the one that if you would hit the space bar, that becomes bigger, okay, that becomes enlarged. So if I were to click on that one and then I execute this one, you can see that I already cast it in a variable, which is a string, because if you would execute just this, okay, you see that this is a string. It is a sequence of letters and numbers, so you have to make sure that this is a string variable. And also again your back quotes. So the active panel in this case is model panel 11, or model panel 1, sorry. Now this doesn't say me very much, so that means that I have to query which camera is active in that model panel right now. So to do that, I looked up how to do that, and there is a model panel command. So let's just go there. Model panel. There's a model panel command which has a lot of flags, and a lot of flags with the query mode. And one of those flags is camera. Camera, query or edit the camera in a model panel, and it has a query and an edit mode. Okay, so which means that if I want to query the camera that is active in a model panel, I just have to write it like that: model panel, the command, put it in query mode, and then query what? The camera, and then put the model panel. Now what I already did here is I inserted, because that is the syntax of this. You see that I have my model panel, the command, then the flags that I want to use, in my case Q and camera, and then the name of the panel. So Maya knows what panel it has to query for, what panel you need the camera for. Because otherwise, if you don't tell Maya what to do or which panel, it will not know. Now, I already put the variable in there, but just to show you how that goes without variables, this would be like that, and then I could just copy that model panel that I have right here, like so, and then I get this top. You can see that this is the top camera. If I use another one, let's say this one here, or let's use this one here, you just see that it's very normal, or very apparent that this is my perspective 1 camera, right? So I query the panel with focus, okay, which I get model panel 4, and then I want to know the camera of model panel 4, so I paste that in here. See that? Perspective 1. Okay, that is the model panel that was active, perspective 1. Okay, now obviously this is the great strength of variables. Again, this is the dynamic part of variables that I talked about. For every user, or for every time you use this script, this is going to be different. Sometimes the active panel is going to be perspective 1, sometimes it's going to be top, sometimes it's going to be shot cam, you know, whatever. So what you have to do is you have to cast this in a variable, and then you have to use that variable in your commands. Again, you remember, a variable is like a little drawer somewhere, and you put something inside. In this case, what do we put inside? Well, in the variable called which case, we put the panel inside with the active, with the focus on it right now. In this case, perspective 1. Okay, but in this case top, in this case side. So this variable will be different each time it gets executed. So each time there can be another active panel in there. Now, once that we put this in that variable, we can use that variable and not the result of this command inside the next variable, which is the name of the camera. Okay, you'll see that I execute that, model panel 4, I execute that. What is in name camera, the variable called name camera right now, is perspective 1. But if I were to create a new camera, so I create a new camera, so, and this is perspective 2, right? So perspective 2 is now active. I execute this one again. See, it's model panel 4, which is the same as before, but it is an other camera right now. You see that the camera is different right now. That means that name camera is the content of name camera is perspective 2 right now. Okay, so now that we know the active panel and that we know the camera that is in that active panel, we just have to query whether the resolution gate is on or off. Okay, now most of the time commands are named, most of the time I say, are named you know, according to what they are doing, or what they are intended to do. So if you want to know information about a camera, or if you want to create a camera, look up camera, and you can see that it lists all the commands which have the word camera inside. So the next thing that we need to know is query the state of the resolution gate. Okay, so we need to know if the resolution gate of the camera that is active right now, in this case perspective, is on. So you go to camera, and then just, you know, as a hunch, you type resolution gate. Okay, oops, resolution. Okay, display resolution is exactly what we need. Thank God it has a query flag. Okay, so activate display of the current rendering resolution when looking through the camera. So you can also obviously edit that. You can create that if you want to turn it on, or you can query it, which means if I were to, for example, write this camera minus query, and then minus, let me just copy and paste it from the help, display resolution, like so. Now this is going to give me an error message, I think, okay, because I have to specify the camera. You see, not enough objects or values. Maya is telling you I have not enough information to tell you what you want. Now if I type perspective 2, which is the name of the camera, and then I hit enter, the result is 0. Okay, 0 means off. You indeed can see that there is no resolution gate in camera 1. Let me go to perspective camera. You see that there is obviously a resolution gate here, and let me change this command to the specification to perspective. Let me execute that again. You see that the result is 1, meaning that the resolution gate is on. Okay, so what we have to do now is we have to base our conditional on that. Okay, so mind the syntax. If, and then I put this command, this whole command, which is nothing more than this. Okay, with the only difference that instead of perspective here, it has name camera, just obviously to get the whole thing dynamic. And one other thing that is very important is, let me close this so I don't keep opening it. No. One other thing that is very important is you see the backticks again. Backticks means that whatever it is in the backticks will be evaluated, and then it will be passed through the conditional, or in this case it will be passed through the variable. So when this gets executed, so let's execute this, see that it is off. Why it is off? Because what is in the camera name. If you want to know what is in a camera name in a variable currently, you can just use the print command, and then you just copy and paste that to see the content of that variable. In this case, what is in the variable perspective 2. So if we go to perspective 2 right here, you see that my resolution gate is indeed off. So this information here, camera query display resolution name camera, you see it is off. Result is 0. 0 is off. So then again we just write the conditional. If this one here is on, so is on like that, if it is on, then turn it off. Okay, turn it off, which means that I put it now not in query mode, the same command, the same camera command, but I put it in edit mode. So I query first if the resolution gate is there. If it is there, so if it is there, then turn it off. Means I have to edit this and then turn it off. Else, if the resolution gate is not there, like in this case, then turn it on. Okay, so this would result in this. Okay, you see that my resolution gate is there now. Again, let me just turn on my overscan so you can clearly see that. There you go. Okay, that means that if I were to execute this whole script, it will just be a toggle. I'm just executing the script. You see it gets turned on and off because it is a toggle. It is checking if the resolution gate is there, then turn it off. If it is not there, turn it on. And the only thing that I did is I just pasted this script in on a hotkey. I'll show you how you can do that. Just go to settings preferences, and then you go to hotkeys, and then you have your user hotkeys. User hotkeys. I cannot find them right now. Actually, if you want to know where you can find that, you just have to go to Windows, settings preferences, marking menus, and then you can go hotkey editor. Hotkey editor. Where are they? Hold on. I can't find them, but this is where I added them to here. So the only thing that you have to do is you just, when you find your hotkey, you have to paste the script in here. You know where it says commands. This is where you have to you click new, and then you paste everything in there. Okay, and then actually Maya will do the rest for you, because it will say do you want that command to be do you want the toggle to be activated when you release that, or when you hit it again, when they hit that hotkey again. So that's how I did that. But the most important part is obviously that you understand this right now. There's a couple of finer points that I would like to discuss. You see that if I remove this, for example, this will still work. That is because Mel and a lot of programming languages have shorthand for things. We'll discuss shorthand more in the next chapter when we're doing iterations. But one of the shorthands is that because a positive a positive conditional is so common that you just don't write this part. Okay, you just leave it out. This is the same as this. Okay, it's exactly the same. If you were to if you want to say is not equal, if it is not equal, you just put an exclamation mark here. oh, sorry, here, like so. Okay, but we'll discuss that later. For now, maybe we can just write it to its full. Okay, I just want to show you that here, because in a lot of scripts you will see this, and maybe you'll get confused. If the display resolution gate of that camera is what? Well, it is just shorthand for this. This is exactly the same as if you leave it out. Okay. Now, as I said before, instead of with focus here, we could, for example, use the other one, which is on the under pointer. Okay, so let's take a look at the difference between these flags. Just type under pointer. Okay, and well, you know what I'll do is I'll just copy this and I'll paste it here, and then I'll just undo a couple of times so I can copy it again, so I can get the with focus. There you go, with focus, and then paste that here. Okay, so let me bring up a lot of them. Let me say under pointer. So I'm gonna execute this command. Under pointer is now perspective 2. Okay, because perspective 2, you can see that perspective 2 is right here, and my pointer is over perspective 2. So that would be model panel 4. Okay, and then with focus is different, because in this case I will have this one in focus now. You see that perspective 2 is focused, but I will hold my pointer over this one. So I'll just highlight this one. Oops, sorry. I'll highlight this one and leave my, I don't know whether that is going to work. That's going to be a bit of a problem. With focus is the one that is active right now. Now the active, you can see that if there is no red line around an active panel, the active panel is the panel that was last active. Okay, so that is the difference between under pointer. Under pointer means the panel that is under your pointer, and the with focus means that the panel that is actually with focus. Okay, the one with the red border around it right here. It's a bit hard for me to explain this right now, because I have to put my pointer inside my script editor so I can execute that command, but at the same time I should be having my pointer over a panel. Anyway, that is the difference between both. Good. I hope you understand this. This is pretty nice stuff, and yet it is very simple to do. Maybe I'll explain it again in short. So the first thing that we're doing is we're getting the active panel. Why are we doing that? Well, because we need to be able to create a hotkey for the camera that is currently active. Now, to get the camera that is currently active, you need to first query the panel that is active, and then you have to query the camera that is active in that panel. Okay. Once you know the camera, you can query the fact whether the resolution gate is on or off, and then all you have to do is write a simple conditional where you say that if the resolution gate is on, if the resolution gate is on, like so, then turn it off. Otherwise, turn it on. Okay, good.